So, how are you all doing? Doing well?
Yes, sir.
So, as I had said, we in the last few classes we talked about the four pillars of engineering, right? So we talked about how engineers do things and use the four pillars like the methodical approach, the practicality of engineering, and then we talked about abstraction, which is science and use of science, math and science. And then we talked about creativity also, how engineers are creative. And so engineering has a lot of opportunity for somebody to be creative. So we talked about all those. Today I wanted to touch upon some of the career part. When we say career, we need to talk about the education also. So today we'll talk about what's a career and job. Um, and change is the only constant. You can stop change, so things will change around you, and how you will manage, or how can you manage yourself, and navigate through all those changes. That's extremely important. And then engineering education, a little bit we will talk about engineering education. And if you are interested, I can talk about studying abroad also, because I did my master's in the UK, and I did my PhD in the US. So I know a little bit about how to go about studying abroad. So as I always say, this has to be um, you know this is not a one-way street. So this has to be a two-way street. You folks have to ask me questions around, if you're interested in to know what all things about engineering education or studying abroad, or about engineering careers. Please stop me and ask. Okay. um, there is a difference between career and a job. Here is the definition. Actually, career is a series of jobs that you do during your work life, and especially if you continue to get better jobs and earn more money, that's a career. On the other hand, job is just some work you do to earn money. For example, I can tell you, my career has been in oil industry, but I was a technical services engineer when I joined in Indian Oil Corporation. That was my job. My job was a technical services engineer supporting customers on, um, our products, technicality of our products like fuels, lubricants, things like that. But then when I joined GE, I was more of a technologist and I was developing things. Again, my career was very similar. I was I was doing similar things, but my job was not a technical services person. My job was um, a technologist who develops technology. So that was my job. Again, I moved to Exxon Mobil Corporation. My job again changed, more product development and research and all sorts of things. But then if you look at it, my career hasn't changed at all. I'm in the same area of expertise, same area of the industry, all those things. But I changed my jobs. That can happen. Why this is important? You need to, you know, please ask me questions, but then what's happening today is much different than 30 years before, or like our parents generation usually used to have one job. They just got a job. My father used to work in KSRTC. That's the only job he had. That's it. And he never changed his job at all. But uh, his whole career was one job. So, but in my case, I have already changed many jobs. But then I mostly my career has been in the oil industry and oil related, fuels, lubricants, engines related. So, but today, what's happening is people might even change careers. Somebody may be a software developer, and he or she can go into a totally different career, maybe consulting or architecture, or we know people who have just gone into hotel business. So, or restaurants, whatever. Today, that's what's happening. You may not have a long career, one career. Instead, you may have shorter career with, people um, opting for those kind of things. Any questions on career and job? Now, why do I say this? I mean, career, you folks are going to have shorter career, but then many different careers. Before that, okay, let's talk about what should be your ideal career. Any idea? What should be your ideal career? Yeah, I'm showing here something. Then we'll go into it. Ideal career is the bullseye of uh, the best of the intersection of all these three things. One is if you can do what you love, and then you may love a lot of things, but then somebody has to, um, yeah, and somebody has to pay for it, what pays well. And not only that, if somebody has to pay for it, you must be good at it, right? So these are the three things. When you choose a career, this is the way you must choose. I mean, all the time it doesn't happen. It doesn't sit right in the center. Even for me, or I know for Satish or anybody, it doesn't sit right in the middle. It may be a little, skewed towards. Sometimes you love it more, but then it doesn't pay you well. Sometimes you're really good at it, but then you don't really love it. But then sometimes you get a lot of money, somebody pays you to do that job, but then you don't really love it, or even so it can get squeezed a little bit. But then um, ideal job is this way: you love it, you are good at it, and somebody's ready to pay for you. For example, you may be an artist, you may be, drawing pictures and painting, all those things. But if somebody doesn't pay for your paintings, you don't make a living. That cannot be your career. That could be your hobby, right? Or as I said, I can play cricket. Nobody is ready to pay for me to play cricket. So that becomes my hobby instead of my career. And here they have given very good examples. Like it can, instead you don't sit in the middle. If you sit right here, what happens? It's just a dream because you love it, and you're not really good at it. So it's just a dream. It doesn't really work. You have to be good at it, right? This thing to work. You love it, and somebody's ready to pay, but you're not good at it. You have to be good at it. Otherwise, you don't make a career. Look here, you love something and you're really good at it, but nobody's paying for it. You maybe you're happy about what you do, but then you're poor. Nobody's paying. Look here, you are really good at something and somebody's paying for it, but you don't love it. You're rich, you get money, but you get bored. You don't. That's not a great career, because if you don't love what you do, then you are not passionate about it, and then it gets boring. So that's the way you need to think about it, because you folks all have a lot of time. Always think about it. Think about it. What I love. What can I be good at it? And then what pays. And if you love engineering, one good thing is, oh, you love engineering. And then when you go to a college of engineering, you learn engineering. So and you can get really good at it. And engineers get good pay. Engineers are not the best paid people on the planet, but engineers get excellent pay. So engineering is a great career. If you like it, if you love it, you can really make a great career out of engineering, and it sits pretty much right in the middle. So that's an advantage of engineering. Any questions? Come on, you must ask 10 questions to me by now. Okay, so I said change is the only constant, right? Everything changes. 5 years ago, or I'll take an example. Look at CE 100 to CE 1000. We call it common era. It used to be AD and BC, but then today people use common era. So in CE 100, like, and if imagine if somebody slept at CE 100 and he came back in 1000, there's no much of a difference. Houses used to look very similar. People were using horse buggies forever, or horses, or in India, bullock carts and those kind of things. There was no much of a change. If you look at it, if I slept in 100 and if I came back in 1000, I would understand the world easily. I don't have anything new to understand. Good, but maybe culturally a little bit of a change, but it's pretty much the same. And again, if I sleep in CE 1000, if I come back in 1700, it was almost the same again. It didn't change another 700 years. Again, it didn't change much. But if I slept in 1700 and if I came back in 1900, man, I would not fathom the world. I would be completely lost. I won't even understand what's going on. Man, what is this? This is New York. This is one of the first skyscrapers humans built in New York City. Multi-story building. What is this? I wouldn't understand, because in 1700 people didn't build anything more than 4 stories. And what is this? A steam locomotive. Man, I wouldn't understand what this is, because in 1700 still people use horse buggies. That's all. And in 1900, by that time, Carl Benz had already invented a motor car that runs by itself. Really? There's no horses and that thing runs? It can move by itself and carry load? I wouldn't understand what that is. So in 200 years, the world changed like day and night. Completely changed, right? Now, why did it change? Why did it change so significantly from 1700 to 1900, the whole world?
So because people wanted sophistications to make their lives easier, and they had to develop more sophistications. And in this process of developing, we created many new revolutionary items.
Humans always wanted to get better. We all lived in caves and in forests and Kalahari Desert and all those places, but we moved. We always wanted to get better. But why didn't it happen it could have happened in CE 100 or in CE 1000. It didn't happen. Why? But
The Industrial Revolution.
yeah, great answer. Industrial Revolution. And what powered Industrial Revolution? And why didn't the Industrial Revolution happen again in 1000 or in 100 or before that?
So to make a wild guess, I guess they didn't find fuel for such developments, like locomotive or something like that. But then when they found the raw materials used, then they started to develop.
Humans had discovered coal and copper and oil and all sorts of things many years ago. But we didn't know how to use it. We didn't know how to use oil. We didn't know how to. We used to burn coal, but when we didn't know how to use coal, really now. The difference is science. We figured out something called science. Humans couldn't have built a skyscraper without calculations. Science started pretty much from whom? From Galileo, right? Galileo started. He built a telescope and showed people that You know, until then, people thought only things, all the heavenly bodies have to go around the earth. Everything was earth centered. It was all geocentric. But then Galileo showed people, you know, with a telescope, a crude telescope, he showed people that, you know, if you look at the Jupiter, there are so many, you know, satellites of Jupiter going around Jupiter. If you have a simple telescope, you can still see whenever Jupiter, if you can observe. I have done that many times. It's fun to see those Galilean moons of Jupiter. So he showed that, and then he started scientifically thinking about gravity, and he showed that you know, almost gravity works the same way by rolling different heavy things and lighter things move the same way because of gravity. But he couldn't complete all those. But then someone, maybe the most genius person ever lived, Isaac Newton, came up with a proper scientific methodology. Scientific methodology. What's a scientific methodology? Actually, the scientific methodology was not defined by Isaac Newton, but it was mostly defined by Francis Bacon. The scientific methodology is you need to have a hypothesis, and then you need to test the hypothesis using experimentation. That's the difference. Humans never ever did proper experimentation and come up with, you know, evidence-based, data-based approach. We didn't have that. Along with it, Isaac Newton showed you can abstract physical things like strength of material or heat or fluid flow or anything for the matter into mathematical models, to equations. Force, he defined force. Everybody knew force. As I said, 9 million species on the planet know that there is force, something, but then they don't define the force. They cannot model the force. But Isaac Newton defined the force as mass times acceleration from the second law. So from there, we can calculate. We started calculating things. Isaac Newton could easily calculate the cooling rate of something, you know, Newton's law of cooling. Isaac Newton defined something called viscosity of fluid. Fluid viscosity until then was you touch and say, oh, the honey is very viscous, milk is not that viscous, water is even not viscous at all. That's the way people used to say, but Isaac Newton clearly defined what viscosity is, you know, rate of shear and shear stress, the ratio of those. So he came up with those mathematical models, and that changed the whole thing, right? Then you can calculate the load on every member of a building, and then you can build a skyscraper. Then because you can calculate, you have mathematical models, you can calculate the steam engine, you know, about the steam and steam power and things like that. And then you can clearly build a steam engine. You can calculate the power of a steam engine, the efficiency of a steam engine. Then furthermore, the IC engine required much more thermodynamics, you know, a new scientific methodology called thermodynamics. And then people developed IC engines, you know, internal combustion engines. And then, of course, along with it, everything happens once there's a tipping point, you know, it goes on. It's like a floodgate, you know, opening up of a floodgate. So, and then along with the industrial revolution started, then it's a nice, good, you know, circle. One feeds back into another. It's a feedback loop, right? Like you have industry funding the science, and science gives a lot of ideas to the industry. Man, that snowballed into huge, massive industrial revolution. So that's how the changes were so quick. And today, the changes are even more faster, right? In 1950, you know, the light bulb used to look like that. And then we developed all sorts of things, you know, airplanes, and then refineries in early 1900s was the, you know, the century of chemical engineering. They built all sorts of chemicals, refining and plastics and all sorts of things. But from 1950s, it has been the era of electronics, right? The left bottom corner, what you're seeing is the computer lab at MIT. And then we moved to the people thought, you know, that's all entire big building was a computer. And then the changes were so quick. And again, by 1970s, we had personal computers. And today, your phone is a much better computer than that whole building, right? Your phone has more computing power than Apollo 11, right? So that's the way things are changing very quickly. Things are changing very, very quickly, right? From 2000, and when iPhone was invented in 2007, I think so. Nobody would even believe that you can build a phone without the keypad. Everybody thought you have to have a keypad for a phone, but Steve Jobs showed people that no, you don't need a keypad. Why do you need a keypad? Today, everyone has a touch phone, right? So things change so quickly because of science and math and science and engineering. Of course, engineering is the use of all these math and science, right? You guys good with the changes happening and why that is happening? Is that clear?
Yes, sir, we are clear with that.
So to put it in one word, the change was science. Today we have science, right? For us, you know, we as we talk today, look at it in about when was the great the Spanish flu? The Spanish flu killed millions of people in what 1918 or something like that, right? 100 years ago, there was a huge flu, and the people were dying. People didn't even understand what's going on, and they didn't have a vaccine or anything developed those days. Today, within a year, we were able to identify all this virus and the strains, and then we were able to come up with a vaccine, right? So quickly because of science. Without science, millions would be, you know, dying, and all of us will be hungered down inside our homes. So, but now a big change is happening, a huge change is happening. You all know that's automation and artificial intelligence, right? Right around you, pretty much everything. You just Google something. Google is using so much of artificial intelligence to tell you the answer of your question. So much of artificial intelligence. And you can talk to machines now. Machines will answer. Your phone has so much of artificial intelligence, right? And in every field, in engineering, you can see so much of artificial intelligence going on today. And, you know, machine learning, robotics, we use a lot of robotics in manufacturing, even in process design and everything. We use a lot of robotics and IoT, Internet of Things. In my world, you know, we have a lot of machines in the refinery. We can see the health of a pump, a compressor, or any machine. You know, we can see the real time. We can see the health of those machines and how they're doing using an Internet of Things, because we have sensors on those machines, and then sitting on a computer, I can see, you know, the temperature of that bearing or how that oil is doing, all sorts of things using Internet of Things. And some of the airlines, you know, in their mission control rooms, they can see every plane engine conditions, you know, because they have sensors, and those engines and those sensors continuously send signals, and they have the Internet of Things, and they can see the condition of an engine. So when that plane lands, people are waiting, the crew is waiting to change something on that, or to service something on that plane, because of Internet of Things today, which was unimaginable a few years ago. And then 3D printing is taking over. Like, you know, you know, if you have to build a car engine, there are thousands of moving parts, but that may not be the thing in the future. If you have to, you don't have to build thousands of parts and assemble each part into in a glue. You don't have to. You can just 3D print stuff. Just give a command, and that prints your thing. So, and then biotechnology, man, changes are happening like crazy in biotechnology. They say they can even 3D print your heart or your liver in a few years. So things are happening, right? Stem cell research and in biotechnology is going like unbelievably. If you're interested in biology and technology, biotechnology is a great career, great career. And then autonomous cars, right? There are Google or many companies already have autonomous cars. You don't need a driver. They can drive better than the humans. But the problem now is, I don't know how many of you follow the autonomous cars. Most of the time, the accident is caused by human drivers because we are, we don't behave like machines. We are whimsical, right? So somebody was leaning for his coffee or adjusting the AC or the radio, and then you get hit by somebody else. So, but then the autonomous car is not like that. They're not whimsical. They're coded, right? They just go by the command. So if it's all autonomous cars, then there won't be any accidents. But then if there's humans, the autonomous cars don't know how the human is going to actually behave. So, and today in most of actually my cars or any car we drive, we have cruise control. You can keep one speed, but an adaptive cruise control. If you put in adaptive cruise control, if something is in front of you, the traffic in front of you slows down, your car slows down, applies brake and slows down by itself. And then if the traffic moves by itself faster, then the car accelerates by itself. Those things, because so many sensors and parking, there are cars that can self park. A lot of cars have that facility now. If you opt for that, the car will. You don't have to do anything. Just press self park and then don't do anything. It'll go and park. So in a proper parking lot, I don't think in Kerala you can park at all. I mean, that self parking would die if you ask the self parking to park in Kerala. But then if you have a proper designed parking lot, it can park. So everything is changing. That the whole point is things are changing. Question? What you see here is it's a complicated chart, but then the key point here is Oxford did a study. When was this? Maybe 5-6 years ago. They did a study about what jobs are going to be automated. So this was a comprehensive study, and that this paper is available online. It's like 50 or 54 pages paper. You don't have to read all those, but the point is a lot of jobs are going to be automated. So they were looking at the probability of jobs that are going to be automated. So you can see to the right, about 47% high probability of these jobs getting automated. To the left, you can see very low probability of these jobs getting automated. And in the middle, there are some. So it looks like about 47% of the jobs are going to be gone for automation. But there will be some jobs created, right? A lot of jobs will be created, but then they won't be anywhere near to the number of jobs that are going to be automated. So you need, when you select a career, you need to look into this chart. Look at sales related thing. Sales and related are going to be highly automated. Services will be heavily automated. Even today, no call centers. Most of the call centers have so much of AI, artificial intelligence. You just ask them, they will tell you most of the things, and that's it. No more call centers. And then look at this, the office and administrative support. Every office used to have so many admin staff. Today, in our company, man, in our research, I think whole entire, our pretty big group we have, and we have 2 admins, just 2 admin ladies. That's it. It's unbelievable. But and we used to have so many administrative support staff. No more. They're all automated, right? You can do most of the stuff online. So why do you really need? You don't have to print stuff. You don't have to even print something and sign. You can do a document sign online. So things are getting automated. So look at this chart when you get a chance and understand, what is going. But then if you look to the left, there are some glimmer of hope. If you look at, say, for example, this thing here, It's education, legal, community service, arts and media. Those things have to be still, oh shoot, sorry, have to be done by humans. And look at the green thing, healthcare. Some of the healthcare things, if you have to get a jab, even today, you need to get an, like an injection, or you need to get some help, hospice help. Somebody has to help you. And then there are some some niche kind of services that are not going to be automated. And you can see some of the management and business, you can see, they won't be automated either. Some business and financial, and you can see something, computer engineering and science. Still humans need to be there to do computer engineering and science. Because why? Because you have to develop the computers going forward, right? If you're going to do more and more AI, you need more and more computers. You need more and more science. You need maybe instead of just doing the binary computing, you may be doing a quantum computing, right? So those kind of things, you are going to improve the technology. So there should be humans to improve the technology, right? So this is an important learning you can do from this work. And I think they have done not only Oxford, this is University of Oxford in the UK, but there are many universities and many companies have done these kind of studies. And you can see, the trend is pretty clear. A lot of jobs are going to be gone to automation. So when you choose a career, it's important for you to choose something that is, it won't be gone very soon. One thing about India is a very, very young country. So it's both a challenge and it's an opportunity, right? When most of the world is aging, like the Western world is aging. If you look at the US, India average age is about 25, but then in the US it's 39 years. It's huge difference in Japan, and it's 48. In China it's 37. So they don't have this young population. So the challenge is to educate and provide this young folks with like you with a lot of opportunities. But then once you give opportunities, these young folks can build a nation very quickly, right? And a lot of energy, a lot of ideas, so that's a great opportunity right there for India. So how you can use that, that's most important. Now, I've been talking about change. So what matters is, so what, right? So what? What can you do about this? That's the way you should think. Everything will change. You cannot control the change. World will change. But what can I do about it? How can I navigate the change very well? That's the way you should think about. Or how can I make these challenges into my opportunities? Always there'll be challenges, but your brilliance lies in converting all these challenges into your opportunities. That's the way you should be. I mean, we all had huge challenges when Satish and I graduated. We didn't even get good jobs those days, but we had plenty of challenges. But unfortunately, we were able to, take on those challenges and reach to a reasonable level. Satish has been an entrepreneur. I've been working in research and doing okay. In our generation, the challenges were different from you folks. But today, how to navigate the changes, that's the way you should think about it. One thing, always you have two, I would say there's a fork in the road. In your career, I can tell you clearly there's a fork in the road. Oh, what is a fork in the road? You can take one of the two ways. One is, if you're passionate about something, if you're very passionate about something, go ahead and do it. You are going to be successful. If you're passionate, you will put in a lot of hours and you can become excellent in what you really love. So always think about if it is going to pay you, and then all those three things I talked about before. But if you're passionate, it's easy for you. For example, A.R. Rahman, when he was 5 years old, he knew he's going to be a musician, and he used to spend 18 hours on a piano. And then when he was 10 years old, he could play for the best musicians in the country, like Ilayaraja. But A.R. Rahman is a genius. Why I'm comparing? But he knew his passion so well, he became a genius and best at what he does. So if you have passion, follow that. There are a million examples of those passionate people who made it big and changed the world, right? Um, but then most of us are not that passionate about things. One thing. Second thing is, at your age, you don't know what your passion is. Honestly, I didn't know what my passion was at your age. I realized my passion for research and education and those things later when I was working in Indian Oil as a technical services engineer. And then I switched, you know, I did my master's and PhD and all those later. So I realized my passion a little late in my life, but then that's okay. That's okay. Anytime in your life, there are people who realize their passion even after 60 years and made it big. It's possible, right? So, but then if you're not passionate, then you need to work on a few things. You have to be, you know, if you still don't know what exactly you want to do, then you need to work on it. But one thing I always say, life is not linear. You cannot plan your life in the sense to the T, to the detail. You should have a plan. You must have a plan. Definitely, you must have a plan. But then it can change in the course. It's not bad, you know. You can always change the course, and you know, life is not linear. A lot of people thought he or she is going to be a painter or a dancer, but they ended up somewhere else. Somebody thought he or she is going to be a teacher, but ended up in, you know, as an entrepreneur or a financier, whatever. So you never know what exactly your calling is and where life takes you. You never know. But still, what is important then? Important is to have the transferable skills. If you're not passionate about things, if you really don't know what your calling is still, but you can work on these things. You generate transferable skills and soft skills that will help you in any job. Mind it, it could be any job. It could be sales, it could be marketing, it could be technology, it could be research, it could be painting, it could be acting, whatever. But some of these skills are kind of universal. You can apply these into any job. So if you're good at those, man, you made it. People will hire you for you know, good jobs. What are those? I would say, you know, being organized is extremely important. If you're organized and if you can think through things in a systematic way, and you can organize things, you can do you know, things in a very systematic and organized way, that makes your life much more easier, and the people around you would love you because, you know, it's easy to work with you because you're very organized. So that's a very important skill. And then you can develop it. It's pretty easy to be very punctual and housekeeping, you know, your desk looks you know, well organized and things like that. And whenever you have a meeting, be prepared for the meeting. Even, you know, when you have a class, prepare for it. That's always good for you. And people love it. You know, if somebody's prepared in that meeting, oh man, people love you. And especially if you're a young engineer or a young professional, and in the meeting you have managers and folks like that. And then when you come prepared, you know, the elder people, the seniors always, I would say, they all love that if somebody's prepared. And nothing, human is all about our brain, right? We cannot beat a lion or a tiger or an elephant one on one, right? One on one, they will beat you in a split second. But then we can use our brain and we can tame anything. We can tame an elephant, we can tame a tiger, we can tame a lion easily because of our brain. So what you have is your brain, your analytical skills and critical thinking. That's extremely important. And when you say critical thinking, always think about critical thinking. What is critical thinking? A teacher might teach you something, but that may not be true. Always ask, is that true? Or why is it true? Or how is it true? Why does that work? That's critically analyzing things. It's not just, okay, teacher told me this, or it's in this textbook, this is there, so I'm trying to understand this. That's not the way you should be thinking. You should always ask question things and then think. Then your brain really works, and then your brain gives you a lot of ideas. That's extremely, extremely important. In any job, critical thinking is extremely important. And I have given all this, some of the soft skills, public speaking, leadership, always take leadership. Don't wait for somebody else. Conflict management, decision making, time management, stress management, communication. I can talk about each of these for hours, for sure. I have taken class about time management. I have taught classes about decision making and things like that. So it can go hours and hours and hours, but that's so think about all these, and whenever you can work on these. The most important thing I would say is having a growth mindset. Growth mindset is extremely important if you want to grow in your life. What is growth mindset? Have you heard of growth mindset, by the way, any of you? No? Growth mindset is simply this: I can get smarter. The belief and your, it's not just belief. The way you act, the way you put in your effort is that you always know that I can get smarter and better by learning, by making the required effort. And if I spend more time on something, I can become an expert in it. I can do much better and I can be a higher achiever. You know how? If I put in the effort. This is called growth mindset. I can tell you, when I graduated from college, I didn't know anything about lubrication. I didn't know anything about oil industry. I didn't know anything about IC engines. Now today I'm a reasonable expert in all these, but then I learned all these on the job because I knew I can learn these and I can become an expert in this. And I put in a lot of effort, many, many years, of course. I don't know if any of you read this book called Outliers by Malcolm Gladwell. Have you heard of the book called Outliers? Any of you? I'll take no for a silence. Okay, silence for a no. Okay, so in Outliers, he clearly brings up the 10,000 hour rule. You can become an expert in anything if you put in 10,000 hours. That's the premise of that. So some people become an expert so quickly, like going back to A.R. Rahman. A.R. Rahman might have put in his 10,000 hours by the time he was 10 years old. But usually to put in, for an average person to put in 10,000 hours, it takes about 10 years on a particular thing. So somebody is an expert in 10 years. But then if you're passionate about things, you can put in so much of effort and become an expert in an area easily. So you put in more effort. So that's the whole point of growth mindset. If you put in effort, if you're ready to learn, you can become an expert in anything, and you can be a high achiever. You can achieve anything. So that's possible. That's important. That mindset is extremely important in your life, because as I told you, things will change, without your consent, without even knowing, the ground beneath you will shift. So what do? You have to learn new things, and you have to have that growth mindset. That's extremely important in your life. So these are the transferable skills and things like that. And I would say always, see, I'm talking about so many things, but then if you critically analyze what I'm talking about, you will have so many questions. So always critically analyze. Don't just take my word for it, okay? Just critically analyze. Okay, what is growth mindset? Why should I have a growth mindset? Or what is it? Those kind of questions, and then then you would do much better, and your mind, you will remember these things if you critically analyze things. Okay, it's easy to remember things, and then your brain works much better when you're critical. All right, let's move to engineering education. As I said, engineering is all about these four things: methodical approach, practical skills, abstraction, and creativity. In an engineering education, this is what they want you to do. They teach you a lot of methodical approaches. That's what they do in a college of engineering. All this, for example, if you're going into electrical engineering, you have to learn a lot of a lot of things about electricity, electrical circuits, and control theory, and all sorts of things, right? Or if you're a mechanical engineer, you need to learn a lot about strength of material and forces and mechanics and things like that. So how to methodically analyze things using math and science will be taught in a College of Engineering quite a bit. But then practical skills, unfortunately, our colleges are not great about those. But you need to always, if you're going to engineering, always look for opportunities to improve your practical skills. More experimentation, more building stuff, those kind of things. We are a little, on the back seat on that one, but then we need to in our engineering education. And then next is abstraction. Abstraction is math and science, plenty of math and science. They will teach you all sorts of math and science to do all your engineering analysis in the College of Engineering, plenty of it. So I have no qualm about that. And then creativity, unfortunately, most of the people don't think that engineers are creative, and they don't allow you to be very creative. They in the engineering education, that's one qualm I had is they don't really bring out your creativity. They don't really tell you that you're supposed to be creative, unfortunately, but you are supposed to be creative on the job. That's what you do. You create stuff, you design stuff, you build stuff. So creativity is extremely, extremely, extremely important. These are the things you learn in a College of Engineering. And then I want to touch upon these things like, what's the difference between an IIT, NIT, there are all sorts of colleges if you consider colleges, right? There are different layers of colleges, IIT on top, then maybe NIT, and then some of the premium private colleges, and then some of the government state colleges, and then some private colleges that are really low. So there are different tiers of College of Engineering. And getting into IIT is not easy at all. NIT maybe, but then, so you need to realize your potential and where you want to go, decide and shoot for it, right? So when you apply, you always apply to top schools, middle schools, and then, some bottom schools, right? So that, when I say school, colleges. Here in the US, it's all, undergrad school and grad school. Here, even university is called school in the US. So that's the way you choose where to apply and things like that. And I wanted to touch upon one important point before we leave. What makes up a higher education institution? What's a university? Or in India, mostly it's all colleges and very few universities, right? But then in the West, it's the other way around. Most of these colleges are part of university on one campus. Mostly a university will have about 10 colleges on one campus, and that's it. Everything is, they are completely independent, and they develop the curriculum, they give you exams, and they give you grades, they give you degree. Everything is done there. So independent universities, and many of them are research universities. They put in more effort in research. So that's the way West is. But then in India, it's completely different. We have tons of colleges. So what makes up a good college or a university? Let's call it a college for simplicity. What makes it? What makes up? When you look at how I choose a college, a lot of kids ask me, how do I choose a college? Always look at these things. Number one thing is the faculty. When you say faculty, the teaching staff, the professors there, or assistant professors, lecturers, why are they called faculty? Nobody in higher education, in universities, they're not called teachers. They're called faculty because faculty is kind of a, it means a lot. It's not just one thing. It's not just teaching. They do research, they do scholarship. So it's faculty have more knowledge, and it's kind of, it encompasses all sorts of meaning. So faculty means, highly qualified with a lot of knowledge, with those kind of faculty. When you choose a college, if you want to be, if you want to really get the best education, choose a college with the best faculty. That's extremely important. For example, IITs have the best faculty in India, IITs and IISc, and some of the institutes have great faculty in India. And then infrastructure, that's very important. Many colleges, some of the private colleges, unfortunately, even some of the government colleges don't have the real infrastructure that is required to teach you engineering, right? You need a lot of good labs, a lot of instruments, a lot of, all sorts of things, in good technology, for example, for even the AV, audio, video technologies and things like that. So look at a college that has excellent infrastructure. Again, IITs have great infrastructure, but NITs have good infrastructure too. Good infrastructure in NITs, and some private colleges I have seen excellent infrastructure, some of them. So when you choose that, that's important. And then students. Why is it important? Students are important because most of the time you don't spend with faculty. Most of the time you spend your time with students, other students, your friends and your roommates and all sorts of students. So through your interaction with these students, you learn so much, quite a bit. And you learn to live, and you learn a lot of cultural things from interaction with students. So if you have wonderful students, for example, you can get MIT courseware on MIT website. You can study anything. You can learn all those MIT courses online. But then is it equivalent to going to MIT? No, absolutely no. Because MIT has completely different kind of setup. That brings me to the next thing, the culture of an organization. That's extremely important. IIT has its culture. NIT has its culture. Government Engineering College Thrissur has its culture. So you need to know what kind of culture a college, a university has. Why is MIT and MIT? It's not. MIT is arguably the best engineering college in the world. Why? It's not just the buildings. It's the faculty, the students, and a culture they have built up in the last, MIT is more than 170 years old, I think. In the last so many years, they have built up a culture. So culture of an organization is extremely important. Because when you go there, you start to imbibe that culture, right? When you spend 4 years on a campus, you start to get, without your knowledge itself, you start to form that culture and bring that culture into yourself. So that's why culture is very important. If you go to some of the, I know some very low level colleges don't have excellent culture. So always look for the faculty, infrastructure, then good students and culture when you choose a college.
So international colleges are more better than in culture and in infrastructure than the central government institutions in India.
There are many universities in the Western world. Actually, if you look at the U.S. has more than 3,000 universities, I think. But then you have to choose, to your ability, even if you don't get to the top ones. If you look at, I can say the 200th university in the US would be much better than any university in India. If you choose one of the 100 universities in the US, that will be much better than any university in India. Much better. You can't even compare an IIT with the 100th ranked university in the US. So much of difference in infrastructure, in faculty, in research, in students, everything for that matter. So that's the thing. So when you choose, look at the rankings. US News ranking is excellent. Even higher education, Times Higher Education ranking is excellent. So look at the rankings, and then you can read about these universities. So always just don't. It doesn't. It's an excellent question. It doesn't mean that universities in the US, so that should be a great university. No, there are crappy universities in the US also. But then US has, if you look at the top 200 universities in the world, maybe 100 universities will be from US. So US has disproportionate amount of number of great universities in the world compared to any other country. And in Europe also there are great universities. UK has many, I would say the top 50 universities in the UK are extremely good universities, because I studied in the UK also. and in Europe and in Australia. If you look at the top, I would say 20 or 10 universities in Australia are extremely good, and a couple, maybe 2-3 universities in New Zealand are really good. Canada has about, I would say, 20 great universities in Canada. So look at the rankings before you choose, and then, you know, and read about the universities and and then, you know, your ability, your test scores and things like that before you choose. That's an excellent question. Any other question? And I wanted to quickly touch upon the study abroad thing. How can you study abroad? I mean, if you want to do undergraduate, like an engineering degree in the UK, US, or Australia, any country, it's possible. You may have to take the required test, like an SAT in the US, those kind of testing, and then you can go. But most important thing about studying an undergrad degree in another country, especially in the developed world, is very expensive, right? It's very, very, very expensive. So you need to look at the benefit versus how much you're paying. So you can say, here people would say, you know, education per dollar. So if I pay $1,000, what do I get? So that kind of a thing. So you need to look at you have to do a cost benefit analysis. And then depending upon your capacity, your parents' capacity maybe, or your family capacity to spend money. So that's very, very important to do an undergraduate degree. Honestly, I come from a poor family. Our family wasn't rich at all, so we couldn't even think about doing an undergraduate degree even in a private institution. Fortunately, I got into a government college, so it was very cheap for us. So it was okay. But then I did masters when I got a real good scholarship. So even when I went to masters, I didn't have enough money to fund my education. But then I got a scholarship, so I was okay. For my PhD, I didn't spend $1. For PhD, always in the West, PhD is completely funded, so you don't have to spend any money. They fund you completely. So I didn't even spend $1 during my PhD or even my masters. But masters is always not funded. I would say maybe 10% of the students would get scholarships. But there are universities, there are places where you can get good scholarships for masters. It's always possible. You don't have to. If you're really good, you can get scholarships for masters, and PhD, of course, always you can get it.
So, sir, if like I get a seat in central government institutions such as IIT, and then even I get a seat in a chance to go to some international renowned colleges like MIT or University of Waterloo, then which one should I choose, IIT or the renowned international colleges?
If you can afford, if you can get into a real good top
like
class,
sir, I get a scholarship in all these colleges.
Scholarship is for undergrad. Scholarship is really, really hard. IIT must be the cheapest on the planet with that kind of name, because government funds completely. So IIT will be very cheap, but any other college for any other great universities in the world are very, very expensive. For example, MIT's today, MIT cost of attendance will be $300,000 for 4 years, which is a huge sum of money. But then MIT is MIT, so you get a degree from MIT. It's a passport to the world. So I would say, if you can afford, choose a great university in a developed country than IIT. But then if you cannot afford, IIT is a great education. Getting into IIT is not easy. You know, the acceptance rate must be 0.5% or something like that. So getting into IIT is so hard, and IIT is so cheap. And once you have an IIT degree, it's so easy to get a master's or a PhD abroad. So easy. You can just walk with that IIT certificate. You can just walk into one of the top class universities in the world. An IIT degree is a passport to the world too, surely.
So,
Again,
so like, which is more valuable? If I have an IIT certificate degree, then can I like also settle in abroad or any places over there, but with my IIT degree?
No, you cannot settle. See, settling in another country requires something called, a work visa first. If you have to work in any other country, you need a visa to work there. And then there are different countries have different kind of permanent residency. After you stay in a country for so many years, for example, in Canada, if you stay for 3 years, you get a permanent residency there. They give you a permanent residency. Then if you stay there for 1 more year, you can apply for a citizenship in Canada. So there's a process you have to go through to become a citizen of that country. In the US, it's a little more, it's longer. To get an H-1B visa, that's a work visa. And then to get a green card, it takes very long in the US.
Green card. Yeah, I know.
Today, the green card takes anything between 10 to 15 years. And then even after you become a permanent citizen, a permanent resident, to apply for a citizenship in the US, it takes another 5 years. So in the US, it takes anything between 17 to 20 years to become a citizen. It's hard in the US. They have made that like that, especially for people from India. If you're born in India, because of the tremendous Indian inflow into the country. That's why that happens. But then in Australia, it's so easy to get a PR. Or in New Zealand, it's very easy to get a PR. In Europe, again, if you go to UK, it's very hard to get a PR there. Extremely difficult to get a PR in PR as a permanent residency in UK. Or in European countries, it's really hard to get a work visa or a PR. But then if you want to settle in another country, you may have to study there. With an IIT degree, you won't be able to just come and settle here. No, absolutely no. You may have to come here, and I mean, when I say here, US, but then any other country, you may have to go there and do a master's or a PhD, or mostly people do master's and then settle there. Then you get a work visa, then you get a PR. And I can tell you Canada, Australia, New Zealand are great options. US is a great option too, but then it takes a while for you to get a citizenship in the US. That's only.
So like my mom told me that if you study somewhere over there, and then if you perform extraordinarily, then you have more chances of getting the green card and getting a residence over there. So if I study in such renowned colleges like MIT or something over there, and I perform great, then will I have more chances to get a permanent residency over there?
It depends. In the US, if you have an undergraduate degree, say, let's take MIT, the best engineering college in the world, and then you get a job. So whatever you are, you have to first get an H-1B visa. Then you get a work visa. Then you start working, and then there are different ways of when you file a green card. There are different 3 tiers of filing green card. If you're an extraordinarily brilliant person and if you have inventions and things like that, then you can file for an EB1 category. There are 3 different categories: EB1, EB2, and EB3. If you just have an undergraduate degree, usually you have to file an EB3, which takes forever. And if you have masters and if you have a little more credentials, more experience and things like that, you may have to file for EB2. And then if you are extraordinary, you have inventions and you have a PhD and things like that, then you can file for EB1. In my case, because I have a PhD and I have patents and experience and things like that, I filed EB1 and I got my green card quickly. Yeah, so it depends on your credentials. Yeah, that's true. But then
so now you're a permanent resident in US? Or
yes. Yes, I am.
So how long were you there?
I've been here 14 years. Yeah, I came here as a PhD student, and then after PhD, I got jobs. So I took a job at GE. Then they filed me an H-1B visa. I got an H-1B visa to work here, and then because I have, as I said, I have a PhD and I have patents and things like that, I filed EB1. EB1 is very quick, so I got the green card quickly. So. But then if you are in Canada or in Australia, that doesn't really matter. If you live there for 3 years, you get a PR, and then in a year you get a citizenship. So you go to pretty much any university in Canada or in Australia or in New Zealand, you can get a PR so quickly, so easily. So that won't be a bad idea. I mean, it all depends upon you, right? What you want to do. So I'm not saying you should do a particular thing, but then I'm just giving you examples. Just think about examples. And it all depends upon you, what you want to do. End of the day, right? So, and anytime if you guys have questions, you know, you can ask questions on GrainEd. People like me, and there are so many other mentors who have done degrees from outside India. So they all have a lot of experience and expertise. So you can use the GrainEd platform to ask these kind of questions anytime, right? Anytime. I think pretty much that's all I had. As I said, you know, from my experience, I can tell you, you know, being organized and, you know, if you can do good documentation, you are always a valuable asset and people love you. And then decision making is extremely important, you know, always. Where do you want to study? What kind of job you want to do? Your life is pretty much decision making every day, from what breakfast you want to eat to, you know, until you sleep, you know, exactly. Your life is all about decision making. It may be small, it may be big. So decision making is your life, and understand and be good at making decisions. It's very important. Then continuous learning, as I said, you know, have a growth mindset and learn continuously. That takes you, you know, that makes you better, takes you to better heights. And then always push the boundary. You can get a job and sit there forever, but you know, the whole world can change, the ground underneath can erode. So, you know, you always have to be pushing your comfort zone, out of your comfort zone, and, you know, become better. And then continuously look for opportunities. Wherever you are, always look for opportunities, always, you know, and explore. And always think about what you are, instead of doing things that people might tell you, oh, do this. No, always do what you are, what you want to do, you know, because you are an individual. You are what you are, you know, end of the day. So do that. And then learn to communicate. I can teach a class for 10 hours about communication, but then there are classes in GrainEd about communication. So, you know, learn more and more about communication. It's very, very important. Even if you're an engineer, communication is extremely important. So learn to communicate and have a mentor. See, this is a great thing about, you know, Satish, we never had a mentor. Unfortunately, if you have a good mentor, you always get excellent insights from their experience. So that's why we started this platform like GrainEd. You have great mentors on GrainEd, right? People with so much of expertise, so much of experience, so much of insights, so much of passion. So, you know, use the GrainEd platform to get that mentors, you know, and use those mentors to your advantage, you know. So that's awesome to have mentors in your life. And not only on GrainEd, great platform like that in school, in college, in your work. Always try and use mentors. Okay, so these are the lessons I learned from my work life.
Which subfield of engineering did you choose, like computer engineering or mechanical engineering? Which one would you prefer for, you know, later studies?
Again, you know, some people love, you know, some sort of engineering. So if you, as I said, if you're passionate about something, just follow that. If you are not passionate, I would say now computer related things would be better, because that's growing like crazy. If you're a computer engineer, you are in demand. You get a job like the day you graduate, you get a job. So computer related things and automation related, artificial intelligence related, it doesn't have to be exactly computer engineering or computer science. There are so many other things, electronics, mechatronics, those kind of things. Wherever automation things are more and more, you know, prevalent, and or you get a lot of you know, expertise in those kind of areas. I was very passionate about chemical engineering, so I didn't even think twice. I just took chemical engineering. But then that need not be your case, right? So if you're passionate about, go for that. If you're not passionate, think about what is growing and where I can get a real good career, you know, or job. You know, think about those.